Hey there, let's talk about a misconception. Some people think that when I take the square root of a squared plus b squared, it equals a plus b. So we're going to find out if that's true or false. I call it a misconception because some people are like, it's true, and others are like, it's false. Before I even get to that example, let's just work on something simple. How about if we look at the square root of 9 plus 16? If this was true, then that means I would be able to take the square root of 9 plus the square root of 16, and it would be exactly the same, because that's basically what you're telling me here, right? Okay, so what's 9 plus 16? 25. So if you take the square root of 25, that's just 5, right? Okay. So I'm still trying to figure out if this is true or not. So what's the square root of 9? 3. And the square root of 16? 4. And you know what this is as well as I do. It's 7. This doesn't work. This doesn't work. If you're thinking that the square root of a squared plus b squared is equal to the square root of them individually, which would be equal to a plus b, if this is what you're thinking, based upon the example I just did, this is false. If I can find one example where it doesn't work, it doesn't work. It's false. Now, remind me of something. How do I know the square root of 25 is 5? We're like, because that's 5 times 5. So technically, the square root of 25 can be written as 5 times 5, right? Observation. That's a multiplication problem first and foremost. And I'm multiplying two of the exact same terms. And the square root says you need two of a kind in order to find the square root of, in this case, that number. That's the reason you end up with 5. How do you come up with the square root of 9? Well, you're like, well, that's just 3 times 3. Multiplication again, right? How do you know the square root of 16? Well, that's just 4 times 4. Multiplication again, right? So in order to take the square root, you need a multiplication problem is what you need. And as soon as you have the multiplication problem, and hopefully there's two of a kind being multiplied together, then you know the square root. So if I take a look at this example over here, I have the square root of x squared minus 9. Now let me ask you something. Does it equal the square root of x minus 3? Hopefully your answer is no. Let's prove it. Based upon what we know about taking the square root of 25, the square root of 9, the square root of 16, what operation do you need to have in order to take the square root? You need a multiplication problem. So, how do I take x squared minus 9 and make it a multiplication problem? Ah, that little 6-lettered concept called factor. Okay, so gratefully this one's nice to factor. It's x minus 3 times x plus 3, right? I have a multiplication problem, but do I have two of the exact same parentheses being multiplied together? No. Therefore, the square root of x squared minus 9 stays exactly as is. Or write it as two parentheses under the square root, but this would be the final answer to you finding the square root of x squared minus 9. Cool? Okay, so I have a couple of examples coming your way. Work on them before you find my answer key video, and please keep in mind that in order to take the square root, you need a multiplication problem. If you don't have a multiplication problem, this isn't true. You won't be able to find the square roots individually. Okay, have fun with this, and I'll catch you on the flip side.